Okay, this is Unit 2, Lesson 3 on three-variable systems, and students will solve three-variable systems algebraically. Just a warning as we go into this is easily the longest problem we'll do all year. You'll notice I didn't say hardest, I said longest. These problems are very involved, but everything we do we already did when we did the last lesson. It's all about elimination. So let's take a look at what we're talking about with three-variable systems. Now in three-variable systems we have three equations and three variables. You can't solve for three variables without three equations, and three equations may or may not have a solution if you only have two variables. So this is what we're talking about when we have three variables and three equations. But we also notice that there's no exponents, square roots, or fraction denominators or anything like that with variables. So it's still linear. So the first thing you have to understand is how can we tell if something is or is not a solution to the problem? Now this is going to be how you're going to check your work when you're done. So in this case, we have 1, 3, negative 2. We need to ask, is that a solution to this set of equations? So the easiest thing to do is for every x, you plug in 1. For every y, you plug in 3. There's a typo on the last one, I'm sorry. And for every z, you plug in negative 2. So let's check the first one. 1 plus 2 times 3, which is 6, so it's 1 plus 6. And that gives us 7. 7 plus and negative 3 times negative 2 is positive 6. So 7 plus 6 is 13. So that first equation is not true. And I automatically know, since the first equation is not true, that this whole system is not a solution to this system. In order to be a solution, every single equation has to be true when I plug in the three variables. So it's not a solution. I don't even need to check the other two. Okay, so let's do the same thing with this other potential solution. So we plug in negative 1 for x, plug in 2 for y, plug in negative 2 for z. We check the first equation. Negative 1 plus 2 plus 2 is 4. Negative 1 plus 4 is 3. And negative 3 times negative 2 is 6. And we're adding across, so 3 plus 6 is 9. That checks out. What about the second one? Negative 2. That's negative 2 minus 2, which is 0. I'm sorry, which is negative 4. And then add another negative 4 to that, because 2 times negative 2 is 4. You get negative 8. That checks out. Negative negative 1 is 1. So 1 plus 6, that's what the second term ends up being, is 7. 7 plus 8, which is what the third term is 15. So negative 1, 2, negative 2 is a solution to this system. So now, how to solve it? Well, this one's pretty easy, because if I look at the y terms, I know that I have a positive 3y in the middle and a negative 3y on the top and bottom. So I know if I add the first two equations, what we're trying to get is we're going to eliminate one variable at a time. I'm sorry, let's get that started. If I look at the first two equations, it's going to be pretty easy to eliminate the y. And if I look at the second two equations, again, it's going to be pretty easy to eliminate the y, because I have the same value with different signs. So I'm just going to add those up. So x plus 2x is 3x. The z's, 3 plus negative z is 2z, and negative 4 plus 15 is 11. And the y's cancel out, they're gone. On the one on the right, now I have 6x minus 2z, because the y's cancel out, and I have minus z, and then 15 plus 19 is 34. So now I've effectively eliminated the y variable and come up with this new system of equations. That's just the two equations I had before rewritten. So I have 3 plus 2z equals 11, and 6 minus 2z equals 34. And again, we're in that good situation where if I just add them up, one of the variables is going to cancel out. So I do that. And I get 9x equals 45. In order to solve that, I just have to divide by 9. And x equals 5. Now that's just one of the variables. In order to fully get full points on this, and to say you fully solved the system, you have to have all the solutions to all the variables, not just x. So I take that x equals 5, and I plug it back into either one of the two equations from right here. And I pick the first one, but the second one would work equally as well and give you the same answer. So 3 times 5 gives me 15, plus 2z equals 11. Then I subtract 15 from both sides. I get 2z equals negative 4, and divide by 2 and get z equals negative 2. So now I have 2 of the 3, and I need to find the y. So I have to go all the way back to the beginning to find the y, because that's before it was eliminated. And I plug my x and my z into any one of the equations. I'll choose the first one when all things are equal. So again, all I do is replace the x with 5, because I know x is 5. and I replace the z with -2 because I know the z is -2. So I have 5 minus 3y plus 3 times 2. I multiply those out. 3 times -2 is -6. I combine the like terms. 5 plus -6 is -1. But the -3y is all still there. I add 1 to both sides. I get -3y equals -3. I divide by -3, and it gives me y as 1. So the final solution to this is the ordered triple, 5, 1, -2. An ordered pair is x, y. An ordered triple is x, y, z. Unfortunately, that was as easy as you can get when you have 3 variables. When you don't have the obvious canceling out, it gets a little tricky. So let's take a look at this one. You can see that none of the variables have all the same values for all the x's, all the y, coefficients, I'm sorry, for all the x's, all the y's, and all the z's. So none of the variables are going to cancel out if we just add them up. So we're going to have to take an extra step. So I'm still going to take the first 2 and pair them together. And I'm still going to take the second 2 and pair them together, but I'll get to that later. And you'll just follow the blue line and find it. Now for these ones, I'm going to eliminate z because z is the only one where I don't have to multiply the top and bottom. If I just multiply the bottom by 2, I'll have 4z on both equations. So I don't have to change the top one, but I'm going to multiply the second one times 2. So it's going to be 6x, 6y, 4z, and -6. And now when I add those up, I get 11x, I get 4y, and I get -3. The z's, of course, cancel out. So I'm going to hold on to that one and use it later. I have to take that blue line, the second 2 equations, and cancel something out. Now, since I canceled out z in the first set of equations, I have to also cancel out z in the second set of equations, or I'll have variables that don't match up. So in order to cancel out z in the first set, in this set, I need to find the common multiple. The common multiple of 2 and 3 is 6. So I'll multiply the first one times -3 and the second one times 2. That's going to give me -9x minus 9y minus 6z equals 9. There's no reason I picked minus for the top and positive for the bottom. You could have done it the opposite and you'll get the same answer. On the bottom, it's everything's times 2, so I have -2x, 10y, and 6z. I add those up. -9x plus -4x is -13x. -9 plus 10 is 1. The z's cancel out, and 9 plus 6 is 15. So I take that one and combine it with the first equation. The equation I got from combining the first 2 ones.
Mr. Crispy, please call 2000, Mr. Crispy.
And now I have a new set of equations with 2 variables and 2 unknowns. And I'm going to go about solving that the same way I would from last time. Now in this case, again, the 11 and the 13, I'm going to have to find a common multiple, but the 4 and the 1 that goes with the y, that's easy to find a common multiple. I don't have to change the top one. And I multiply the bottom one times -4 because that's going to give me -4y. So -13 times -4 is 52. That's 52x minus 4y. And 15 times -4 is -60. Add them up. 52 plus 11 is 63x. The y's cancel out. And then I get -63. I divide both sides by 63. And I get that x is equal to -1. But again, that's just the start. I have to find y and z yet still. So I plug in -1 into that equation right there where it's pointing. That's -13 times -1 plus y is 15. Well, that's 13 because -13 times -1 is 13. 13 plus y is 15. I subtract 13 from both sides. I get that y equals 2. Now I have to take those 2 back into one of the original equations. This is way back from 3 slides ago. So I plug in the x, which is -1. I plug in the y, which is 2. And I solve for z. So it gives me -5 minus 4 minus 4z. That's -9 minus 4z because -5 minus 4 is -9. -4z is 12 because I added 9 to both sides. Now I divide by -4, and z is -3. So I found x, y, and z. I put the answer in an ordered triple, which is -1, 2, -3, and that's my final answer. If you wanted to check it, you would go back in and plug x, y, and z into all 3 equations, and they should all give you true statements. Here's the homework for today. It's 3 problems because they're very long. Remember, we have a quiz at the beginning of next class, and we're going to start something that seems completely new, but is actually going to tie into what we're doing here. So good luck, and I will see you next class.